Man, what could be causing this ping pong ball to float? Is it magic? Just kidding. This can be explained through a physics concept called the Bernoulli's principle. Bernoulli's principle. Bernoulli's principle. Which states that the faster the flow of a fluid, like air, the lower the pressure that is exerted, allowing this ping pong ball to remain suspended even as I move the hairdryer side to side. Now if I apply this paper roll, the velocity of the air increases, providing a sudden decrease in pressure, shooting the ball up. Now let's take a closer look into what can explain this amazing phenomenon. Here you can see the wind forces at play. As you can see, the arrows warp around the ball, creating airflow that increases velocity above, generating lower pressure according to Bernoulli's principle. This causes the ball to flow upwards until it equals out the downward gravitational force, remaining relatively suspended. Even as the ball hovers out of orbit, the greater atmospheric pressure pushes air against the ball and into the column of low pressure. Here is a look at the molecular level of the principle. Above, you can see how the particles in the thinner region have more flow, not only have a greater velocity but bumping less into each other, meaning less force/pressure. Below, the wider region has less flow, but the particles bump into each other more, creating more pressure despite being slower. So, why should we care? Well, Bernoulli's principle can be used to explain how airplanes fly, like this one or this one. Here is the airfoil that acts as a representative cutout of an airplane wing. As you can see, the airfoil is angled so that the velocity is greater towards the top of the airfoil while lower towards the bottom, creating lower pressure being exerted from above onto the airfoil while more pressure is being exerted above, generating lift. Even though there are other factors of lift, Bernoulli's principle helps us unravel one of science's many mysteries.